Good afternoon, folks. Today we're going to explore how to get more familiar with R as a calculator. So R can easily add things like 2 plus 2 or pi times 3, etc. Just remember to always use your PEMDAS priority rules, parentheses, exponent multiplication, division as well. And there are a few unusual characters that R can use, such as the INF stands for infinity. So any number divided by infinity returns 0. I want to go ahead and show you how to do a couple of other things with R as a calculator. So I'll just sit my RStudio right here. And I'm going to go up and open a new file to get a new R script. And let's just go ahead and do a couple of little simple things here. 2 plus 3, and of course I'm going to hit run to get my result, which is 5, as you can easily see. But I also want to show you that R kind of ignores spaces. So here's the same expression, and I get the same result, obviously, but notice that R just tends to ignore spaces. So just think about that whenever you're writing your own script or code. Now, a lot of times we like to assign R a particular number. And we do that using an assignment error. So right now I'm going to assign the answer to an object. And that object is, in this case, x. So 2 plus 3. And so now I've assigned that as x. I don't have to use x. That's just common in algebra. I can use other things. For example, I'm going to assign Wilbur as 2 plus 3. And I could also assign Martha using my assignment arrows as 100 divided by 10. And now the beauty of this is I can add those two variables together, just like you would in any particular script or program. So Martha plus Wilbur. And I can run those, and I get 15 as my answer, so 5 plus 10 gives me 15. So as befits a programming language, it can divide, multiply, etc., but not all of its answers are what we might expect based on our work with things like TI calculators or Excel spreadsheets. For example, we could enter, let's see, log 10. And we might expect, those of you who know a little bit about logs, expect one answer. We actually get 2.3, which is the natural log, not the log base 10. So in R, to make a log base 10, we have to go log 10 of x. Or in this case, log 10 of 10. And we can run that, and we get 1, and that's the expected answer. So we can also ask more than one question of time. For example, we can ask R to give us the integers from 1 to 10 inclusive, and we can do that very easily using this expression, 1 colon 10. And you can see down at the bottom that gives us an array of 10 elements. So here we ask the question, and R returned us 1 through 10, but we have this little bit of a kind of an annoying little bracket of 1 that tends to show up a lot of time in our answers. R is really being brief here and assumes that we know that all the other answers are elements, so it only lists 1 at the beginning of each line. If I had, for example, did this 1 to 1,000, you can see that it lists 10 elements in each row, and it lists the element number at the beginning of each row here on the right. So I'm going to go ahead and clean this off now, and we'll go back and take a look at a few other things that I wanted to share with you. So here are just a few of the other mathematical functions that we can use in R, such as exponents, sine, square root, assigning exponential notation, which is at the bottom. Note that the angle is in radians, and R, that's how R typically does it, but you can, of course, assign it degrees if you wish. Here are a few of the operators that we might use. We have expressions for the extremes, min, maximum, range, rounding, square root, the various trig functions, various logarithms, the symbol for infinity, and down here are some things that we'll start seeing when we look at data sets, like NaN is not a number, or NA is not available and an empty set is null. Now there are other operators that we can get with R, and these are called logical operators. The less than sign is known as a logical operator. Others include the two equal signs. If we have two equal signs together, that means two things are equal. If you see the exclamation point, it means are two things not equal. And if you see the long upright vertical bracket, which is on the right-hand side of your keyboard, it means it is one or the other thing true. So those are the various different kind of logical operators, and you can see those in there. Here's the exclamation point, and here's the double arrow. And here's just a list of the logical operators that we might be using. In fact, we probably will use many of them throughout the course. There are a couple of different ways to get help in R. For example, you can just type a question mark and say log or box plot, and it will give that to you. There are other ways that we can get help in R, and one of my favorites is just using the help function. So you can see here I have ANOVA. But I can also look for almost anything I want. Let's say I want to know about the logarithm. So I can just type log, and I'll get a little bit of help in R. Logarithms and exponents. I can ask it for how does it like to speak about pi, and it'll tell me what the built-in numbers mean, and etc. And we can also go back and do more complicated things such as ANOVA, and it'll come up with various help packages to help me with that. So there are a couple different ways to get help. I like to use the built-in help in RStudio. Now, the next thing that we need to do is learn how to add packages. And packages are just collections of functions with specific tasks. We're going to be using one called vegan a lot. In a few moments, we'll load one called SMP Practicals. Some of these packages are installed by default when you put in R. For example, car is done that way. Others have to be installed manually, and I will show you how to do those. Many of them have example data sets, and some are associated with even books, tomes of packages. So a couple of ways to do it. One, you can just use the word install packages, and then in the parentheses you put the name of the package that you want. And all of them are going to come from the CRAN project. Once you actually install a package, you have to load it, meaning that you have to go ahead and say, take it from the computer's built-in library and put it into R's working memory. The search command can be used to see what packages are actually loaded, and I encourage you to use that in any particular time in case you forgot what package that you're interested in. So let's go ahead and do that now. Let's go ahead and load a data set here. I'm going to make my screen just a little bit bigger, hopefully, so that things will be a little easier to see. And I'm going to get rid of this because I'm not interested in saving it, and I'm going to open up a new script. And let's see. I very quickly already pasted this into memory to show you what I wanted to do. So here I'm going to install all packages used in this script, and you only need to do this at the first time that you run the computer. And the packages I'm going to install are SMP Practicals, and the other one's called ggplot. And the Practicals is a statistical modeling practicals package. That's where the name comes from. And ggplot2 is a grammar of graphics package version 2. So we're going to use those to look at a particular data set. So to actually do these things, of course, I'm going to have to take my library and make all this run. There we go. There we go. But I want to show you another way that we can do it. So we can go over here, and I actually like to use this way. It's the way that I more commonly do it. Let's say that I want to install a package from CRAN. And I've told you that we're going to need to use SMP Practicals. So I type SMP, and with a little luck, R is so very helpful. It tells me that the package is up. I want to install all dependencies. Those are other packages that SMP Practicals might be dependent upon, and I hit install, and it might say I want to upload it. Yes, I don't really have a choice. If I say no, the computer just sits there and there's not much I can do. So of course I'm almost always going to say yes to that kind of prompt. And then the other one was ggplot2. So let's go ahead and type ggplot2, and there it comes up. Install dependencies is checked, and there we go. It's all downloaded for me. And it's installed, and it's in the library. Great. So now I'm ready to run some things. So in this SMP Practicals, there's a particular data set that I kind of wanted us to look at. And it's a really famous data set put together by a very famous geologist and biologist, and now we call him an evolutionary scientist, named Charles Darwin. And Darwin did an experiment where he was looking at inbreeding depression. So this is kind of our first environmental component that we're going to look, or an ecological component in this course. And so he planted in a series of pots, which he put in Roman numerals. So he's got 4 sets of pots. He put in different pairings, and he would put in plants that have been cross-pollinated and self-pollinated. And he figured those that would be self-pollinated would be inbreeding. He was looking to see what their fitness might be. And the height, which in this case is measured in inches, was a surrogate for fitness or ability to reproduce. So this is Darwin's data. And I thought it might be appropriate right now just to show you real quickly how we could plot data like that up. First, we want to look at the structure of the data, and we'll talk more about that in next week about structure of the data. But I just want to show you how helpful R can be. So here I've got qplot, which is going to be built into one of these packages. We're going to do type, which is the cross or selfing. I want you to understand how I'm using this script here. We're going to plot height, so we're going to plot type and height. Our data is going to be the Darwin data that we've done. And the shape, we're going to let it be whatever type is the default, and the color is going to be default, and we're going to use a black and white theme. And we will learn how to change all these themes a little bit later on. But for now, we just want to see how easy it is to make a plot. So I will highlight my script, and I'll hit run, and with a little luck, there we go. There's the beautiful Darwin data. And we can see that it looks, at least at first blush, that those that are self-pollinated generally have less height than those that are cross-pollinated, and we might say that those who cross-pollinated would have a higher degree of fitness. Of course, we would want to check this out with statistical modeling, but for now, I just wanted to show you how we can make a very basic script, installing packages, loading packages, looking at data in one of those packages, getting help if we needed help, and then making a simple graph. So those are some of the kind of the basics that I wanted to cover in this particular lesson. So as I said a minute ago, there are lots of data sets built into R, and we just looked at the Darwin data set. But if you wanted to see what data sets are in a package, you can just type library help data sets, and it'll give you a list of those. Absolutely lovely. And to see which ones are actually in the packages that you loaded, just type data open question, and you'll get that. It is often important when it comes time to write a paper that we cite our information. And so to get the exact citation, you can get that by doing the citation parentheses for R itself, and then you can put the program name in there, such as SMP Practicals, and it'll give that to you in a specific package. And that's something you would certainly want to put in any particular publication. And indeed, when you do a serious R markdown, you would want to cite the version of each package that you're actually using. So we just did our first script, and we used an editor to write the script, and we used our studio to help us. But the cool thing is, of course, once we have that script, it will work every single time. I could modify it. I can change the type of data. I can change the type of plot. But the beauty is the script will work every single time with just simply hitting the run button. So the next thing we need to think about are functions. And so all the work of R is done in a function. And so to call a function is done by writing its name followed by a number. So we have function name, and then within the parentheses are going to be the arguments, the things that you're actually telling that function to deal with are the arguments. So some arguments have a default, and therefore they can be omitted. But the argument names of functions are often recognized by just partial matching, but it's really good to spell things out totally. I already told you that everything in R is an object, and to create an object, you work with assignments. So to make an assignment, we can use the assignment operators, which I did in the very beginning. And we can also create objects in our workspace to see what objects we have created, such as I did Martha and Wilbur earlier. I could use the little ls function or objects function, and it's going to list those for me. If I want to get rid of them from kind of my active workspace, I can use the rm object name. So this might be rm Wilbur. And that will remove Wilbur, and etc. To remove all objects, and I recommend this when you're doing complex scripting. You can use the remove list ls, and it gets rid of everything. The last thing I wanted to cover in this particular lecture was how to close R. So obviously you can just use quit or X out of it, but it will often ask you if you want to save the workspace or not. So if you answer yes, the history will be saved in an R file called R history that you can find on your computer, and the objects will be in a saved file called R data, and they're going to be saved in the directory where you started R or in the working directory that you've set. However, it's often bad practice to do that, since the saved workspace is loaded again the next time you start R, and it can get rather cluttering, especially if you want to start a new project. So this can cause problems and confusions. So my recommendation is never say yes in this particular case. So you can always write no or just say no. And you can, and I highly recommend that you just use the R Markdown as the main way of recording your scripts and your R work. So I hope this has been helpful, and look forward to seeing you in class. I've given you some homework about how to make a couple of graphs. I'm sure you'll do a little Googling on that, and we'll see you next time. Take care. Bye-bye.